Assalamualaikum. This is chemistry 12th, and our today's lecture is about the preparation of these carboxylic acids. In our previous lecture, we discussed the nomenclature and of these carboxylic acids. Now, as far as this lecture is concerned, this is about the preparation of these carboxylic acids. Now, we have got various methods which are used for the synthesis or for the preparation of this these carboxylic acids. Some of the methods I have shown here. One of the method is that is by the oxidation of primary alcohols and aldehydes. Now, in this method, these primary alcohols and aldehydes, they are oxidized using some suitable these oxidizing agents, like we have this acidified potassium permanganate or acidified potassium dichromate. Now, in this case, we see primarily these alcohols, they get oxidized to the they are oxidized they get oxidized to the acids. Now, this is a primary alcohol. You can see here when it is oxidized using any of the above these oxidizing agents, it gets oxidized to the acid, to the corresponding acid. Now, this is I have shown here, this is methanol. Upon oxidation, it gives using any of the two above oxidizing agents, it gets oxidized to formic acid or methanoic acid. Similarly, this is ethanol. This ethanol, upon this oxidation, it gives rise to ethanoic acid or acetic acid and plus water. Now, as far as the aldehydes are concerned, now aldehydes can also be oxidized to these to the acids using these oxidizing agents. This is an aldehyde I have shown here. Upon oxidation, it gets oxidized to this acid. Now, this is I have shown here, this is a methanol. This is methanol or formaldehyde. Now, it is when it is oxidized, using this acidified potassium dichromate or acidified KMnO4, it gets this methanol, it gets oxidized to methanoic acid or formic acid. Similarly, this is ethanol. Now, ethanol, upon oxidation, it gives rise to ethanoic acid. Then we have got again, this is a primary alcohol. Again, this is benzyl alcohol. Although this hydroxyl group is present in the side chain, so this is benzyl alcohol. Upon this oxidation, it gives rise it gets oxidized to benzoic acid plus water. Now, similarly, we can oxidize benzaldehyde. This is benzaldehyde, C6H5CHO. When it is oxidized using any of these oxidizing agents, it gets oxidized to benzoic acid. This is C6H5COOH. So, this is one method for the preparation of these carboxylic acids, that is the oxidation of primary alcohols and aldehydes with these oxidizing agents, that is acidified KMnO4 or acidified potassium dichromate. Then another method is by the oxidation of alkyl benzene, or simply we can call it as toluene. Now, what we do in this method, the side chain or the alkyl side chain or the benzene ring, it gets oxidized, or it can be easily oxidized to carboxylic group, to a carboxyl with alkaline KMnO4, or we can use this is chromic anhydride, or we use concentrated sulfuric acid. You can see here, this is toluene or alkyl benzene, and that is methyl benzene. Upon oxidation with this alkaline KMnO4, and we get this is benzoic acid. Similar, this is second method. Now, another method that is used for the preparation of these carboxylic acids is by the hydrolysis of nitriles or cyanides. Now, in this method, these alkyl cyanides or alkane nitriles, they are oxidized with an alkali or an acid to give rise to the formation of these acids. Now, this is a methyl cyanide, or it is ethane nitrile, we can also call it. Now, this upon acid or alkaline hydrolysis, it gets oxidized to this is you can see it gets oxidized to this acetic acid. So, plus ammonia is also given out. Similarly, we have got this is a phenyl cyanide, or it is benzonitride. Upon hydrolysis with this upon acid or alkaline hydrolysis, it gives benzoic acid. Now this is benzoic acid plus ammonia. So this is second method, that is by the hydrolysis of nitrides or by the hydrolysis of these alkyl cyanides. Then we have got another method that is used for the preparation of these carboxylic acids, that is by the hydrolysis of these trihalogen derivatives of alkanes with alkali. Now in this method what we do, we treat these trihalogen derivatives of alkanes with an aqueous alkali. You can see here this is a trihalogen derivative of an alkane, plus when it is treated with an aqueous alkali, it gives rise to the formation of this product. Now this being unstable because three hydroxyl groups, they are attached to the same carbon atoms. Since OH is a heavier group, so it immediately loses a molecule of water and gives rise to the formation of this acid. Now this is a trihalogen derivative of alkane. When it is treated with aqueous KOH, it first loses three molecules of this KCl, you can see here, then gives product gives this is a product in which we see three hydroxyl groups are attached to the same carbon atom, and I have told you that it is unstable and it immediately loses a molecule of water and gives rise to the formation of an acid. Now you can see here this is trichloro, this ethane. The three chlorine atoms, or they are attached to the same carbon atom, or we can call it as 1 tri chloroethane. So this, upon this aqueous this hydrolysis with KOH, it first loses three molecules of KCl, then it gives this product, and this being unstable loses molecule of water and it gives rise to the formation of this ethanoic acid. So this is another method. Then we have got another method, that is the hydrolysis of esters. Now, as far as this reaction is concerned, in this method, an ester is, first of all, it is treated with an aqueous alkali, and aqueous alkali to form a salt of an acid, which on treatment with a mineral acid like dilute HCl, to give rise to the gives rise to the formation of this acid plus alcohol. So this reaction, as you already know, I have told you about it. This is a sphonification reaction which involves the alkaline hydrolysis of these esters. Now you can see here this is methyl acetate, or we can call it as methyl ethanoate. Now when this is treated with this aqueous sodium hydroxide, it gives first a salt of the acid, that is sodium acetate is formed. You can see here, plus methanol is also formed. Now the salt of the acid, that is sodium acetate, this is then treated with this mineral acid, that is dilute HCl, and it gives rise to the formation of this corresponding acid, that is ethanoic acid plus NaCl. Similarly, we can have this methyl methanoate, or we can call it as methyl formate. Now methyl formate, this upon treatment with this aqueous sodium hydroxide, it gives salt of this acid, that is sodium formate. So methyl formate gives sodium formate plus methanol is also produced. Now sodium formate or sodium methanoate, it is then treated with dilute HCl to give rise to the formation of this is methanoic acid plus NaCl. Then we have another method, that is from alkenes. Now these carboxylic acids can be also got from alkalis on a very large scale by treating these alkenes with carbon monoxide and steam under pressure in presence of this phosphoric acid. So you can see this is an alkene, this is ethene or ethylene. This is treated with this carbon monoxide and steam in presence of this phosphoric acid. This is H3PO4 at this temperature 675 Kelvin. It gives rise to the formation of this acid. So the acid formed in this case has got one carbon atom more than the parent alkene. Now you can see here this is ethene, and we get from this this propanoic acid. Then we have got this is propene. You can see here this is propene. Now this on treatment with carbon monoxide and this steam in presence of this phosphoric acid at 675 Kelvin, it gives rise to the formation of this isobutyric acid. Now, or we can, as far as its EUPAC name is concerned, it is 2-methyl propanoic acid. So this is another method. Then we have got one more method, that is by combination of this Grignard's reagent. Now in this method, this carbon dioxide gas, it is passed through an ethanol solution of Grignard's reagent to form first an addition product. Now this the addition product then formed is subjected to this acid hydrolysis, and it gives rise to the formation of this carboxylic acid. You can see this is carbon dioxide. When it is treated with this is Grignard's reagent, it is this is methyl magnesium bromide. Now you can see this methyl group, it attacks the this carbonium of this carbon dioxide. Now it gives rise to the formation of this is addition product, and this addition product is then subjected to this acid hydrolysis, and you can see here we get this is ethanoic acid is formed, and this is hydroxy magnesium bromide. Similarly, when this phenyl magnesium this bromide is also treated with this carbon dioxide in an ethanol solution of when carbon dioxide gas is passed through ethanol solution of this phenyl magnesium bromide, it again gives an addition product, and this addition product on subsequently when it is hydrolyzed with water in an acidic medium, and it gives rise to the formation of this is benzoic acid, and then we get hydroxy magnesium bromide. So these are the various methods which are used for the preparation of these carboxylic acids. Now as far as their chemical properties and physical properties are concerned, we will discuss them in our next lecture. This is for today. Thank you very much.